All right, I'm going to call that a quorum and go ahead and start on some time. So welcome everybody to this session. First up, we have Julius Krumbiegel from Pumas. He's going to talk about the advances in the Quarto engine for Julia.
Yeah, thanks. So my talk's titled Introducing Quarto's Native Julia Engine, Easier, Faster, Better. I'm a senior product engineer at PumasAI, and let's get into it. So for those who don't know, what is Quarto actually? It's a technical publishing system, so it's supposed to help you create all kinds of documents based on reproducible code, markdown text, and code snippets that are executed, and the results of those are spliced into the final document. So it works like this. You start with some markdown document, a QMD file, a special markdown dialect that Quarto uses. You pipe that into Quarto and render it, and then the code cells that you've defined usually go through one of the available execution engines. So before there was a Jupyter engine for Julia, a Jupyter engine for Python, and a knitr engine for R. And once your code is executed, is put together again with the markdown you've written into a final pandoc markdown dialect. And this is then piped to pandoc, which, if you don't know, is a tool that can convert documents from all kinds of formats into other formats. And this is then used to create the output files, which can range from HTML, PDF, Word, Reveal.js, which is what I'm using for these slides, books or websites. So the range is really, really huge. This tool has been around for a long time. So yeah, there's a lot you can do with this. And the focus is also on reproducibility, right? You don't want to create reports where you copy-paste your assets into it after you've rendered them in some other Julia REPL, but you would want to have everything in one place and be ready to go. So this is what a really small QMD file would look like. You have a front matter section, which you can define all sorts of metadata, like a title or which engine you use, which is the thing that I'm talking about. Then normal markdown looking text with your sections. The sections mean different things depending on what kind of output you have. Might be pages in a presentation, for example, or on an HTML page it would look like a normal heading. And then the code blocks that are executable are these ones with the curly braces. And you have a bunch of Quarto-specific options for those. And then you use your normal code in whatever language you're using. And whatever a code block returns is then used in a suitable format for the output, right? And that's the basic mechanism of it. And in the remainder of this talk, I'm going to talk about the engine for Julia, marked with the orange border here. And it says Jupyter here because that's what the state was before we got involved, right? And Jupyter, as you might know, is a Python tool. So there was always a strong Python connection in the way you had to use Julia with Quarto. And why did we write a native Julia engine then? Like why would we take the time if there was already a working solution? The main reason is the ease of setup, use, and deployment. So we just had a lot of trouble getting things to run reliably for our consultants. And it turned out that there are many pitfalls you can run into when you set up these kind of systems. Even though if they work, they tend to work well. Like, I don't want to disparage the previous solution, but there's just a lot that can go wrong the more moving parts you have in your system, right? And the other reason is that there are certain features. So Quarto historically came out of the R Markdown project, so it's historically very linked to R. So I think the company that does Quarto, Posit, was even called R Studio before, so it was an R shop basically, and you notice that when you go through the Quarto documentation, you notice that a lot of stuff, smaller but useful stuff, is only available for R because historically that's where it came from, right? And so for certain situations, we wanted to have the ability to add more features to the system, and Jupyter wasn't really amenable to that because it's just like it has existed in its state for a long time, and there's not really a way to add features to it easily. So that was the other reason. And I have the snippet here with Moses allowing where he said a couple of weeks ago on Slack, does anyone have an example of a presentation made with Quarto? Like I can't get it to work, right? Quarto check says everything is fine, Python works, and so on. When I try to render, there's some internal failure, like some model that can't be found. And then, without me even getting to it first, said like, oh yeah, I can just add IJulia and everything works without Python. I'm happy, right? So that's great. That's exactly what we wanted to see. So I was really happy to see this on Slack right when I was preparing my talk. So yeah, I wanted to show like what could go wrong basically with the Jupyter engine. So this is just a small mind map kind of thing with the parts that you had to get right in order to render Julia stuff with the previous backend. So you installed Quarto, Julia, and Python. And then the question is, so you need IJulia for the Jupyter part, right? But where do you install it? It's usually recommended in the docs to install it in a global env, which I generally don't like. I don't like things that have to go in global environments, because the more you install, the more trouble you get into. Then in order to make things be picked up by Jupyter, you have to install or register the kernel. And this is another step that can go wrong, especially if you return to a working setup after some time, you have updated something in the stack, and then everything breaks. Sometimes hard to get it to work again. And you kind of have to repeat this process for every version of Julia, because every version needs another kernel. And then it just, yeah, it gets annoying after some time. And on the Python side, yeah, first of all, you need Python. So maybe some people who use Julia, they are not into Python as well. So for them, it's kind of a hassle to get anything to work on that side. And even if they have a working Python, then they still need Jupyter, which can fail, which was, I think, the reason in Mose's case. And even if they have Jupyter, like where do you install it? How can Quarto find it? What kind of env? I mean, there are so many things you could configure there. The same with Python. Like, do you have some global Python installation that's more likely to break over time because you install other stuff into it? If you have a local one via Julia, then there are also a lot of ways by which this can break. Environment variables you have to configure, all kind of stuff. So yeah, that's basically the picture you have for the native engine. You just install Julia, then you install Quarto, and that's it. So there's not a lot that can go wrong. So yeah, like the basic getting started guide for the native Julia engine would look like this. You install your Julia, you install your Quarto, you create a notebook where you specify the engine Julia setting, which I showed you before in the front matter. Then you add one of these curly brace code blocks. And when you then render the notebook, our package, QuartoNotebookRunner.jl, is installed automatically in the background into an env that sits in a local cache directory of Quarto, so it doesn't interact with any other stuff, any other environment on your system. So I've basically never seen this fail. I mean, there are, of course, like with any system, systems can always fail, but this step like of installing it and getting the basic thing to run seems to be very robust, and I'm quite happy about that. The reason you have to specify the engine Julia is that Quarto puts a lot of emphasis on backwards compatibility. So because the engines work slightly differently, they couldn't just make ours the default, even though for most users it should clearly be the preferred option, right? But nowadays, the docs should like mention it everywhere. They put the engine Julia. And you can also nowadays put it into your project settings globally. So if you have 100 notebooks, then you don't have to add it to every one. Right, so the architecture of the system is shown in this little illustration. We have the main package, QuartoNotebookRunner, which spins up a persistent server process, which waits for commands from Quarto to come in through HTTP requests. And there are a bunch of these, like the main ones you're going to use is Quarto render, or a couple of special commands we've added in order to interact with the server process, like call IJulia close to shut down a certain notebook that is persistent, or status just to see what's going on, how many notebooks you have, how long have they been Running, stuff like that. Exactly, and these Quarto Quarto processes are always short-lived. It's just a command and then they shut down again. So what stays in memory is this server process and the workers. And the server communicates with the workers through a socket connection. We were using Malt.jl directly, which is also what powers Pluto notebooks. But over time, we had to do too many modifications for our use cases so that we now use like a vendored fork kind of. For example, one thing that I wanted to mention here is that you can run different Julia versions on the different workers. And you cannot do this, to my knowledge, with Pluto because they use serialization for communication. And so this doesn't work across version boundaries. So yeah, what's Quarto Notebook Worker? That's like the package that we run on each notebook worker process that we spin up. It uses vendor depths to avoid conflicts with user code. So every package we use, we kind of pulled into the repo so that like if we use Bison, it doesn't conflict with any package that you might be using at some other version. And as we heard in the other talk before, there's currently no official way in Julia to do this other than copying the source and including it. So that's what we do. Then this package basically runs your code cells, and for all the MIME types that it wants to have from each output value, it turns that into a byte vector and sends that over. So there's only a small number of types that you need to send anyway, which is why we didn't need the serialization in the first place, like with which you could send anything, but we don't need to. There's just a really small number of things we want to send. So this package also has hooks defined, or you can define hooks in it for re-rendering logic. So the thing is, if you have a persistent worker process, because you want to be quick in re-rendering a document, right? You don't want to wait for the full spin-up every time you do render. So these things wait in the background for you. But of course, like Pluto, basically, we have the same issue that we want to pretend like you're doing a fresh run every time, right? And this just has a bunch of difficulties. Like I was surprised how difficult it is to set up a system like this that reliably just executes code in a persistent process. So an example would be if you do one run in which you set like the black and white theme for Marquee, and the next time you delete it and you rerun it, then Marquee still has this theme set, right? And so everything would look wrong. And so you have to add kind of this stuff per package. Otherwise, you will just run into weird behavior. So that's like the just something you have to accept, right? There's no way around it. So for the packages that we use the most, we have defined integrations like that already. But it's also, and these are defined via package extensions, but it's also possible to do that yourself, but you have to kind of use requires. And the reason is that Quarto Notebook Worker is not a registered package. It's something that lives inside Quarto Notebook Runner and is like loaded dynamically into the process. So currently it's not registered, which means that you cannot define a registered weak dependency on it, because then the registrator will complain and say, like, I don't know this UID. Yeah, that's not ideal, but we have found that, I mean, the main drawback of requires, as far as I remember, is that it doesn't really work well with pre-compilation, but these hooks are usually tiny anyway, right? So I haven't yet seen a case where this was like prohibitive, and it's not the same as for official package extensions where you would really want to avoid requires. Yeah, so for the special features that I mentioned, that we, like certain cases that came up for us where we felt like the Jupyter backend didn't quite offer what we needed, I wanted to go over a couple of those. So one of them is the thing with the kernels. So we added Julia up integration, which means that you don't have to do anything else but adding like a small flag in the front matter to specify which Julia version you want to use. So this is really easy and stateless, so no file anywhere has to be updated or installed to make this work. It's just, that's all that's required. And what we do is we check that the manifest of the project that the worker process loads, that it matches the Julia version that you use. And we do that, I mean, it's not standard Julia behavior. Like in principle, you can load a manifest with a different version, and usually it will just warn. But we want to kind of force a better path to reproducibility and one way to do that is like to avoid mistakes like that, right? So yeah, we will just refuse to load an env which doesn't match the Julia version, which might be annoying in some cases, but as you heard also in the other talk, nowadays you can have multiple manifests anyway for different Julia versions, so that should not be prohibitive and rather be like seen as a guardrail kind of thing. So yeah, one feature which I find really cool that we have added is called cell expansion. Cell expansion is for dynamic document generation, so basically cases where you want to have the structure of your document depend on some kind of runtime information that you have, some kind of data maybe that you put in it. And the way it works is that you have to overload the QuartoNotebookWorker expand function for a given type that you have, return something called a QuartoNotebookWorker cell, or a vector of those, and a cell is supposed to be like a fake code cell plus its output. So as if you had written some code and that code had returned some output. And this whole system is recursive, so if the output of this fake cell again has something that is expandable, then it will happily continue expanding this kind of stuff. So it's not code generation, it's not like you're writing some kind of weird macro-like thing which writes code as if you had written it and then executes it, but it's all value-based, which makes composition much easier. And so to show what that looks like, here's an example. We are using the Quarto tools package here, which is a companion package we also published, which just makes this, it's also called cell, but it's a more convenient version of the same thing that you find in QuartoNotebookWorker. And as I said, QuartoNotebookWorker is currently not registered, so yeah, it's easier to go through this thing if you want to use this functionality. Here I'm defining a function which prints an info statement and it returns values of computation, and then I define one of these cells, pass the function to it, I do the optional argument, the optional keyword argument code where I just pass in some string, and I also set some options, which is also optional. And these options correspond to the cell options I showed you earlier, like these specific Quarto settings you can add to a code cell. And if you then return such a cell in a Quarto notebook Julia code cell, and the output of this would look like that. It looks like there had been a code cell written there which repeats the code that was here, which was not actually executed, right? It's just, it's fake, basically. And the output of this function that's being run. So it captures the standard out or standard error, and it takes the value that is returned and renders that. And I mean, this tree looks very, not very exciting, but imagine this function returns some kind of plot. Then it's really nice that it goes automatically through the MIME type display system, right? Because in other tools, as far as I know, usually when you dynamically generate parts of your document, you generate the markdown directly. At least that's what I usually see. And then it's more difficult because if you have assets, you have to save them somewhere and have space for them, and then take care that you integrate them correctly, and this might differ depending on the output format and so on. And with this system, you just return values as usual, and we take care of putting them into the document for you correctly. So the question is, why would you do this? This seems kind of arbitrary, this, this example. So on the next page, I'm going to show you a more useful case, more useful use case. So this is a feature that Quarto has, which is called a tab set. A tab set is just a way to show information more compactly, right? Like you have different kinds of something, and then you put them into tabs, and you can flick between the tabs, and this saves a lot of vertical space, right? And the way you usually do this is you define a pandoc div, which is this triple colon syntax with some kind of class identifier, and inside that must be markdown where you have a couple headings, and the headings define the tab titles, and the content of the tabs is then spliced into those, right? The problem with this is that you have to hard code it into your document, right? You have to hard code this fence and the headings and all the content, and there's not really an obvious way to do this otherwise. And we often face the problem that we have some kind of runtime data which we want to present in this way, but it would be very annoying having to generate this every time or to hard code it basically. And so how can we use cell expansion to work with this? We have a convenience object in Quarto tools called tabset for exactly this purpose, but the implementation is really simple, and like you would have no trouble implementing your own things you want with the system. So I'm just defining a plot function here, nothing special, it just makes a plot and gives it a title so you can recognize it. Then I make a vector of pairs where the first element is the title of the tab and the second is whatever object I want to be the content of the tab. And when I pass this vector to the tab set object and return that in a cell in the Quarto notebook, then the output of this is basically this tab set with the 5 subjects that I have, right? And so this could be completely dynamic, like you can write a notebook that takes in the path to a data set as a parameter, and then you run this on some data set that has 25 subjects, then it works the same way as if you had 47, it doesn't matter, right? So this gives you a lot of freedom, and as you can see, you don't see any of the pandoc div syntax here, so that's a really common thing for people to waste time on, is to get these fences matching correctly, because in this document it can be really hard to see if you have 5 levels of divs, where the first one ends and the next one and so on. Like it's flexible, like you can write anything you want, but it's also hard to keep track of. And with this value stuff, it's much easier. And the next example I have is just to show the recursiveness of it a bit more, where now I'm not putting one plot object into the tab, but here I have 2 more helper objects in Quarto tools, like markdown, cell, and div. And the div is basically what makes these fences appear that I was writing manually before. And I use a div and wrap a markdown cell in it, which is just a way to shortcut this output as is function of Quarto, which you can otherwise use, where you print text and then it's used as markdown. So this is like a more declarative version of that. And I have a div as well in this where I just put 2 random plots next to each other. And this div, I give another attribute, which is another Quarto special feature, some attribute called layout and call, which makes a column layout. And usually you would write that in the div syntax, but here you just put it inside an attribute. And when I render this, I get 5 tabs where each one has a bit of markdown rendered into like a bold text and 2 plots next to each other. So, and at this stage, that would be really, really messy to write in the normal syntax. So yeah, if you have ideas for how you can structure your documents in this kind of way, then you can save a lot of trouble by going through this object route. Yeah, that's the cell expansion feature. And then the last one I wanted to mention was arc call and Python call integration. So our consultants sometimes want to show how the in-house solutions that we have written in Julia compare to something they would use previously in R or Python. And of course, you can use Python call and R call manually, but it's a lot of verbose overhead to... It doesn't look nice if you have like a string of code there, which is then formatted like a Julia string, so it's just plain green. It's nicer if the code that you want to show is R, is actually formatted like R, and you don't have all this boilerplate added to it. So what we do is, if you have imported Python call or R call, we use them to convert R code blocks or Python code blocks into all the boilerplate that you would normally have to write, and then these packages will be used to execute that code. And the nice thing about that is that you can interpolate Julia data into them, so it's usually easy enough to run the same algorithms on an array that you have constructed in Julia. So the most basic data types work fine with this. And then the output of this you can see on the right, where there's a plot from R, and Python is determining the length of the vector. With a little bit of CSS, I have added, because otherwise, like if you don't do anything, like you wouldn't immediately recognize what the language is that is happening in a given code block. But I've seen the other day that there's now plugin for Quarto to make this even a little bit more obvious with like a small box on top of it that mentions the language. So yeah, but as you can see, it's very clean. You don't see any of the boilerplate, and it's relatively easy to set up. Yep. So that's the last one I wanted to show. Thank you very much for your attention. So if there are any questions, I'd like to take them now.
I'll go first over here.
First of all, thank you for the talk. I think I've run into all of the problems you described with Quarto, so I really appreciate it. And one thing I think with like a notebook interface, sometimes that leads to a very messy development workflow. So like, I don't know if that's something you've thought about in working with your consultants, like how to manage that at all, or is that something you think about? I don't know.
If you could elaborate what kind of thing you find messy, then maybe I can give a more targeted.
Yeah, that's fair.
Like, what thing do you find messy?
Hmm?
What thing do you find messy in the workflow?
Oh, yeah. Well, I mean, I think some of that has to do with like the culture around data science, I think. But, you know, I think I found a workflow where you work outside of a notebook and then get to the point where you're like describing the end story. Like you write a paper, you write a notebook. And that, yeah, I'm getting a little lost in that story. I'm just curious if you've run into that, like the like, whether the ergonomics and like affordances of notebooks work well with like a longer development process.
Oh, okay. Yeah, maybe I can mention, so one problem we run into is that the workloads that we often have in these notebooks, they are pretty heavy. So big models that are being fit and a lot of data being pushed around. And so one problem for consultants, which we are also still working on to find the best workflows, is how to cache the intermediate computations in a way that is easy to use, but also not so hard to mess up, that you're running something with an old version of a computation. Because it could take a while to re-render a full notebook, even if your session is still persistent, depending on how much stuff you put in there. And we definitely sometimes run into this problem that the developers run a 10-cell notebook for testing, and then the consultants run a 1,000-cell notebook for testing, right? And then at some point things fall apart. I mean, they still work, but like the workflow becomes bad, and then you have to think about ways to mitigate that. So yeah, that's an ongoing thing we are working on, how to improve the workflows for our consultants. Yeah.
Thank you. I'm new to Quarto, so I apologize if this question's been asked and answered before, but is there plans or possibility of an interface for Pluto instead of Jupyter notebooks?
So this already doesn't use Jupyter notebooks. I mean, with Pluto, what you mainly get is the reactive execution mode, right? Like you're editing something, you save it, and then Pluto runs the cells that it needs to run. So it has its own persistent storage of the results you already have, and so on. So this is not really reusable for what we have. What some people have requested is a way to take the notebook that they have done in Pluto, because it's nice for development, and then turn it into something that Quarto can ingest. And that is I think a much simpler problem, because it's just about the format of the document. So if somebody was interested in that, I think they could make quick progress there, but we don't use Pluto, so we haven't looked into it further than that. But the only way in which we use Jupyter notebooks, I haven't mentioned it, but that's kind of the output that we create with Quarto Notebook Runner. Like in the background, what we send back to Quarto is an IPyNB file, just because it was a shortcut for development to reuse the post-processing pipeline in Quarto from what was there previously. Because I mentioned the R backend, and this one directly writes the markdown that has to go to pandoc. So they have even more flexibility. And we've run into a few cases where IPyNB as an output format is a little bit limiting, just because of the spec of IPyNB and that it doesn't allow you to do everything you might want to do. But overall, it was definitely a win to just piggyback on that and not redefine the wheel. Yeah.
One more.
Yeah, thank you. This was great. Two really brief questions. One is, I'm guessing this just works with Documenter Quarto? Have you done things with Documenter to generate this and using Quarto tools in that context?
I personally haven't. I think I've seen people on Slack doing it, and that generally seemed to work, yeah. And
then the other is, it looks like the Quarto devs have registered the very nicely named QuartoNotebookRunner.jl with a pretty anemic package. I'm just curious if you've thought about, like, the first thing I did when I sat down here is I was like, okay, I'm going to work with Quarto. I'm going to add Quarto, and that is not the right path. I don't know if you've talked with the Quarto devs, or it looks like that package hasn't been updated in a very long time. It would be kind of nice to just have a streamlined path there.
You mean for the Quarto tools package, to use the name for that, or?
Or, I don't know, like just a high level, or something that might install Quarto for you, or something like that. The QuartoNotebookRunner.jl package doesn't do much currently.
I see. Okay, so yeah, I mean the QuartoNotebookRunner package, you don't have to interact with at all. You don't really see it. Same for QuartoNotebookWorker, so we don't need the name for that. And then there is a QuartoJLL package, which in general works, but it did have a problem recently because of the read-only status of all the JLLs, and there was a small bug with that, which I already fixed, but you wouldn't get it yet with the latest version of the JLL that's registered, just because Quarto doesn't do backports usually, and so I'll have to wait for the next minor version. But that's the easiest way to get started. If you don't want to go to the Quarto website and download Quarto, you can download the JLL as usual, and then that will work, yeah. Yeah, I think Mose also did that in CI, and it was fine, right? Yeah. That was how that thread continued that I had a screenshot of here. So yeah, that's pretty nice.
All right. With that, let's thank Julius one more time.
Thanks.
Next up, we have Akio Tomiya, who's going to talk about Julia quantum chromodynamics.